Reduction to the decision problem. A classical optimization problem can typically be phrased as follows. Find a feasible solution that maximizes some objective function. The decision problem version of this is there a feasible solution for which the objective function has value at least v? A standard reduction between the two involves solving the decision problem many times using binary search over values v. Unfortunately, such an approach will not work for mechanism design as it is not truthful to run several truthful mechanisms and then only take the output of the one that is the most desirable. The following truthful auction avoids this problem. Definition 13.41 RSPE. The random sampling profit extraction auction RSPE works as follows. 1. Randomly partition the bits B into 2 by flipping a fair coin for each bidder and assigning her to B prime or B prime prime. 2. Compute R prime equals to F of B prime and R prime prime equals to F of B prime prime, the optimal profits for each part. 3. Run profit extract R prime on B prime prime and profit extract R prime prime on B prime. The intuition for this auction is that profit extract R allows us to treat a set of bidders B as one bidder with bid value F of B. Recall that a truthful auction must just offer a price Ti to bidder I who accepts if her value is at least Ti. This is analogous to trying to extract a profit R from bidders B and actually getting R in profit when f of b is greater than or equals to R. The RSPE auction can then be viewed as randomly partitioning the bidders into two parts, treating one partition of the bids B prime as a single bid with the value R prime equals to F2 of B prime, the other partition B prime prime as a single bid with value R prime prime equals to F2 of B prime prime, and then running the Vickrey auction on these two bids. This intuition is crucial for the proof that follows, as it implies that the profit of RSPE is the minima of R prime and R prime prime. Theorem 13.42, the competitive ratio of RSPE is 4. Proof. As we discussed above, the profit of RSPE is minima chosen between R prime and R prime prime. Thus, we just need to analyze the expectations of the minima chosen between R prime and R prime prime. Assume that F2 of B equals to Kp has with K which is greater than or equals to 2 winners at price P. Of the K winners in F2, let K prime be the number of them that are in B prime and K prime prime the number that are in B prime prime. Since there are K prime bidders in B prime at price P, R prime is greater than or equals to K prime times P. Likewise, R prime prime is greater than or equals to K prime prime times P. Thus, the expected value of RSPE of B over F2 of B is equal to the expected values of the minima chosen between R prime and R prime prime divided by K times P, which is greater than or equals to the expected values of the minima chosen between K prime P and K prime prime P divided by Kp, which is equal to the expected values of the minima chosen between K prime and K prime prime divided by K, which is greater than or equals to 1/4. The last inequality follows from the fact that if K is greater than or equals to 2 fair coins, corresponding to placing the winning bidders into either B prime or B prime prime are flipped, then expected values of the minima chosen between the number of heads or the number of tails is greater than or equals to K over 4. It is evident that RSP is no better than 4 competitive via an identical proof to that of the analogous result for RSOP. The currently best known competitive auction, which has a competitive ratio of 3.25, is based on generalizing the idea of RSPE. First, the bids are randomly partitioned into 3 parts instead of 2, with each part being treated as a single bid with value equal to its optimal single price revenue. Then the optimal 3-bidder auction is run on these 3 bids. The random partitioning and profit extraction approach is fairly general. For it to work successfully, it needs to be shown that a profit extractor for the benchmark exists, and that up to constant factors, the benchmark is preserved on a random sample of the agents. Notice that the consistency issue discussed in earlier sections is not relevant if only the agents in one partition win. This approach has been applied successfully to several other settings.